Good morning. How is everyone today? Class. My wife is a school teacher, so, pick up some of the habits from that. Welcome. I'm going to be talking today about 2 years ago's buzzword, Docker, no, microservices. But specifically, I'm going to be talking about microservices and their impact on how we think about team structures, organizational structures, and the relationships between team structures and processes and software systems. So this is my hypothesis, right? Software boundaries, right? The boundaries of our software systems are equivalent with team boundaries in the limit of Conway's law. So when you take Conway's law to the limit over time, system boundaries and software and organization boundaries are the same, and therefore you can use organizational boundaries to reason about the cohesion of services, microservices, the coupling of services, what sort of testing we should be doing, which testing types we should be doing on our services at different boundaries, and also which integration patterns we can use. We'll finish up with that. First of all, I'm going to introduce myself. I work for a company called ThoughtWorks. Quick hands up, who's come across ThoughtWorks? Yeah, so the majority. I won't go into too much detail about us. We're a software consultancy. There are about 4,000 people around the world now, 36 offices at last count. I'm based out of the London office, and I've been working as a, principal engineer, coding architect for ThoughtWorks. I've been there about 11 years. I've got over 20 years in the industry, so grey beard. I actually shaved the grey beard off today because it interferes with microphones. So, tricks of the trade. This is us. As I say, we're a consultancy. Consultants, yeah, hell yeah. This is ThoughtWorks. So if you want people like this, or people with beards, maybe come to us. So as I say, I work for ThoughtWorks. We've been involved in building both open source tooling and contributing to literature around software engineering for the best part of 20, nearly 30 years now. In some of these, you can see some of these books we've contributed, so Continuous Delivery, Lean Enterprise, Patterns of Enterprise Application Architecture. Some of the open source projects, I've got more of the Java ones up here, but things like JMock, Selenium, Cruise Control were all built by people who either worked for ThoughtWorks or were working at ThoughtWorks when they built them. Cruise Control, the first ever continuous integration server, and I had to, because I saw a cap over in the far side of the room, I have to say that behavior-driven development was also something that came out of someone who used to work for ThoughtWorks, Dan North. Hi, Dan. This is me, James Lewis. As I said, I've been around for back in the industry over 20 years now. But principally, these days, I guess I'm known for my contribution to the work around microservices. I co-authored this paper with Martin Fowler, trying to define what microservice architectures are. And in that, we call out the characteristics of microservices as we saw them based on what we were seeing teams doing, both internally and externally, that were making them successful at the time. So that's a brief introduction. What I'm actually going to be talking about most of the time is Conway's law and the impact of Conway's law on software and on teams. So this is my first slide. So organizations which design systems are constrained to produce designs which are copies of the communication structure of those organizations. So Mel Conway wrote this down back in 1968 based on a ton of research he'd been doing, where he'd noticed, based on information theory, that depending on the communication pathways between teams, the high bandwidth or low bandwidth communication pathways, so if you're in a team, you've got high bandwidth communication between you and your teammates, right? You can have serendipitous conversations and overhear serendipitous conversations versus other teams, remote teams, different parts of the building or different continents or countries, very low bandwidth communication. System boundaries, over time, will tend to conform to those information boundaries, right? The bandwidth boundaries of communication between people. And that's a really interesting idea. And he came up with this back in 1968. Originally, he was turned down for publication by HBR, Harvard Business Review. They didn't think that there was enough evidence to support this claim. But over time, by the way, this is how I think of Melvin Conway. He's kind of like the Muppet. He's sitting on the balcony laughing at us. You know, he's been, like, since 1968, he's been telling us that this is the case. And he's sitting on the balcony, like, watching us all go off build software, sort of laughing at how we're making the same mistakes all over again. And Noel Conway, he's not in. No, that's good. Some conferences I go to, it's feasible that he would be in the room. So I've got to check, I suppose, but that being too... Anyway, Melvin Conway, a bit later on, Harvard Business Review and MIT got together and did a ton of research. Thousands of projects were examined to test this hypothesis, Conway's law. And the paper was called Exploring the Duality Between Product and Organizational Architectures, a Test of the Mirroring Hypothesis. And in this paper, they found that Conway's law holds, right? So if you structure your organization to have a database team, say, a middleware team, say, and a front-end team, say, over time, you will end up with a system that looks like a front-end, some middleware, and a database. Right? That's basically a statement of Conway's law. This new paper, or the paper that was published decades afterwards, they found that tightly coupled organizations, design becomes more tightly coupled. Software systems become more tightly coupled in a tightly coupled organization. But in loosely coupled organizations, and if you think about the most loosely coupled, often they are open source projects. In loosely coupled organizations, the architecture tends to be more modular, and this is played out in various forms, things like the Linux kernel and so on, and stuff around Unix. So these are the characteristics we called out. And what I'm going to be exploring, rather than talk about componentization via services or how we do transport between services and integration, I want to be talking about these two things: how we organize ourselves around business capabilities and running product development rather than running project development, because these are often overlooked aspects of the microservices characteristics as we saw them. And as I say, these are the things that we saw that teams were doing that were making them successful. So if you think of the Netflixes, the Guardians, the Twitters, etc. I'm going to preempt a question at the end, because it doesn't matter what topic I talk about microservices or around microservices, I always get asked, how big should a microservice be? So I'm just going to preempt that. This is in response to questions at the end. And my answer to this question is, like a normal service is about that big? Yeah? So a microservice is about that big. So you all have learned something, I'm sure. And that's me, done. Awesome. See you later. Not really. So this is the statement, right? Microservices should be cheap to replace, quick to scale, resilient, right? And they should allow you to go, to quote Adrian Cockcroft, former VP engineering at Netflix, now VP engineering at AWS, they should allow you to go as fast as possible. This is the goal. This is why organizations are breaking down their software into much more modular components. But most organizations aren't set up, I suspect, to do this. And I'll give you a few examples of some of the things that happen, or I've seen happening. So this is a group of, I guess, role-based functional silos or, that you see in many traditional organizations. You've got architects, you've got development, testing operations, project management office, sales, marketing, your business functions, right? And a brief digression, this is something called a chord diagram. And what this chord diagram shows, actually, is dependencies between things, right? So the chords represent where one thing has a dependency on another thing. This is actually just, I'm a software developer. I went through a code metrics visualization phase. So this is Spring. The dependencies in Spring visualized using the chord diagram. And when I was going through this, and my interest in org structures and things, I thought, wouldn't it be interesting if you could do the same for organizational structures, right? Use chord diagrams to visualize what happens in organizations. And this is the sort of thing I'm talking about, right? If you've got these silos, architecture, project management offices, and so on, and you plot them on a chord diagram, and you plot the dependencies of work flowing through this system, you end up with something that looks a bit like this. Now, you can imagine what happens here, right? So someone in sales says, I've got this new idea for a feature. It's going to make us a ton of money. It's going to be awesome, right? So they go to the project management office and they say, hey, PMO, we need to start a piece of work on this. So the PMO says, okay, well, we'll create a project. We'll assign a project manager and we'll assign a solution architect, and the solution architect is going to sit there and do some design for a bit, tappity-tap, and then architecture will hand that design over to development, and development will say, oh, cool, we're going to build this thing. Oh, crap, laws of physics, we'll have to hand it back to the architects. So there's a line going back to the architects, and the architects do a bit more, we didn't think about laws of physics, so maybe we'll do this design instead, hand it back to development do some stuff, hand it to testing, do some testing, say, well, this was never going to work, it's totally broken, hand it back to development. That's essentially what I see in many, many organizations. Now, how many of you is that familiar to? Yeah, so a fair amount. Okay, how many work in an organization that's got more than 1,000 employees? Is it the same number of hands? Probably. The interesting thing, well, this is another example. This is a real example from a project, from an organization I visited some time ago of how work flows through the system. You've got the roles down one side, you kind of IT solutions, business development, QA, and then you've got time progressing along the standard axis. Interestingly, that's coding. That's the only bit that's like coding. The rest of it is stuff that's happening, work sitting in queues, which I'll come on to in a sec. And I always sort of think of this sort of system, this sort of process, system of work, as being a bit like snakes and ladders, right? You sort of move one step forwards, then suddenly you hit a problem no one foresaw, and you have to hand it back several steps back into the process to get fixed. So there's another interesting thing that I think this sort of diagram shows, because each of these lines between functions represents something specific, actually. Each of these lines actually represents work flowing from queues into other queues. Queues in one department of work waiting to get done, flowing into queues in another department. Each of these chords represents at least one queue. And I think, if you read this, I think this is one of the most important books to have been written about our craft in, well, its lifetime, I suspect, and it's not even about our craft. It's about product development, but it applies wholeheartedly to software engineering. Principles of Product Development Flow by Don Reinertsen. In this book, he calls out some of the issues with having queues in your system of work rather than software system. And he calls out these simple or rather complicated effects. So when you have queues, specifically when you have big queues of work in your system, right, they create longer cycle time. Right? Work takes longer to flow through a big queue than a small queue. So it takes longer to get done. It increases the risk, right, of the work, because you've got lots of stuff in progress and lots of things can change over the course of work progressing from the bottom of a queue to the top of the queue and actually being done. You get more variability, you get more overhead. You tend to have lots of projects or initiatives. People spend 80% of time on one thing, 20% of time on the other thing, more status reporting, more project planning meetings, more architecture governance meetings, more overhead. You tend to get lower quality over time, and you get less motivated people. Because if you've completed a piece of work and suddenly it has to sit in some other queues for 12 months before ever getting into production, that's pretty demotivating compared to, I completed a piece of work, push a button, it's live, the users are using it. So queues in the system create all sorts of issues related to these 7 things. I like this quote from Peter Drucker, the American management consultant. Nothing so useless as doing really efficiently that which should not be done at all. Or to restate it in a different flavor, to quote Dan North, it doesn't matter if you've got, if your development team takes an infinitely short amount of time to actually complete a piece of work. If it takes you 3 months to define it up front and 3 months to get it into production, it's still going to take you 6 months to get something done. So, systems what I have seen. I'm going to start this off by defining what I see a capability is. I nicked this from Microsoft some years ago. So a capability is a combination of people, processes, systems that provide value to customers, and they could be internal or external customers. Right? So a business capability is the what of a business, but not how the business works. It's not the business processes inside the business, it's the what. If you're a retailer, it's selling stuff and delivering stuff, fulfilling stuff. If you're in banking, it might be providing loans to customers. It's not how you go about providing loans, but it's the stable aspect of your business model. The what of the business, not the how. So this might be an example. This is based on an organization I spent some time with about probably 2 years ago now. And they were a retailer. They were selling tickets for public transport of one form or another. And they'd separated out these two capabilities into delivering stuff and into selling stuff. And actually, selling stuff was in India, actually a big development team in India, and delivering stuff was in the UK, big development team in the UK. And in between these two things, they had this quite nice separation provided by a lightweight messaging bus, and so they'd pass asynchronous messages between these two capabilities. So these are cohesive. One of the things we look for when we're building software systems, they need to be cohesive at different levels of granularity, and they're decoupled, right? So you can make a change in one without affecting the other one. Another property that we would like when we're developing software, when we're building systems of systems. But these capabilities were built by fairly large teams in the different two continents. Not much bandwidth between them. You know, as I said, Conway's laws acting to reinforce the boundaries of these capabilities. But what was happening within these teams, interestingly, is that they were using project thinking rather than product thinking. Now, I see product thinking as this idea of having a stable, long-lived team organized around one of these things, or smaller components of one of these things, as I'll come on to later, that has a backlog that it works through and is stable over time. Versus a sort of project-based team where you have a PMO who gets some requirement from the business, stands up a new team of 3 or 4 developers with maybe a QA or maybe a PM or whatever, and then they dissolve after the work is completed and they hand that completed work product over to an operations team. So short-lived project teams versus longer-lived product teams. And this morphs into, over time, the idea of you build it, you operate it, which is the kind of Amazon 2-pizza team model. So this company, even though they had these nicely decoupled capabilities across the two countries, they were using these project teams to deliver these capabilities. And so what would happen is, you know, a group of developers and maybe a tech lead and a QA and a PM would get together for 3 months to deliver something, and they'd pop into the code base, do some stuff, and then they'd pop out of the code base again, and then like a month later, another few developers would pop into the code base and pop out. This was happening on both sides, and so on. And what ended up over time happening, or over time, what ended up happening is, and I think this is, you know, I'm a fairly lazy developer. Lazy in the sense that if I see, you know, a problem I can automate, I'd like to automate it, for example. But I'm also quite lazy in the sense that I tend to take the path of least resistance to solving a problem. And there was no ownership of these individual capabilities. They weren't decomposed any further than just big chunks of stuff. And as these developers were popping into the code base and popping out again, popping in and popping out, they were taking the path of least resistance. So we ended up, this company ended up with each capability composed of many small web services which were massively coupled to one another. Lots of chatty interfaces, because a developer would turn up and look at the code and say, "Oh, right, well, I need to talk to that thing over there because it's got some information I need, it's got some data I need." Wouldn't bother, because lazy, like me, wouldn't bother to look at the APIs that were already there and just say, I'll create a new web service endpoint. So over time, you had these incredibly chatty comms happening. And I've seen this happen on multiple occasions. And I should reiterate that I'm not using lazy in the pejorative sense here. I'm using lazy and lazy smart, not lazy stupid, right? Or lazy lazy. Oh. What ended up happening with this is over time, they ended up with one of these they were trying to work in an agile way, small a agile, so they were working iteratively in 2-week sprints, but they ended up with this coupled, uncohesive mess that had to be essentially regression tested, deployed all at once, performance tested for 6 weeks. They do iteration, and then 6 weeks of hardening. Right? This is essentially 3 mini waterfalls, right, happening, and then this is classic Scrummerfall or something like that. They also had this problem where, because everything was tied together, very coupled, they had to test everything together. right? So they had all these lovely different services, but they all had to come together into this integration environment for this regression testing, for this performance testing, hardening period. And I see this in so many places. You often get these sort of responses when you ask about why have you got integration environments, end-to-end testing environments and things? Why can't you deploy more frequently? Well, we can't deploy because we need a new integration project or environment for this project, and it'll take us 6 months to get one. We can't use the other one. Or we can't deploy since we are waiting for the test team to finish running tests on a different project that's happening somewhere else. And this starts with these problems you see with distributed monoliths, right? Or where you have to bring lots of different software components, systems together in order to integrate and integration test them together. Actually, this is different. It's a completely different talk, actually, but I do like the concept of end-to-end testing or integration testing being risk management theatre. I heard that as a phrase, which I quite liked. But these are very common responses when you ask, why can't you go faster with what you're doing? And this idea of having to deploy everything all at once is pretty endemic. And it's because even though we're using remote calls to access other services, say, those services aren't actually decoupled. They're normally temporarily coupled together. So what you end up doing is building up inventory, waiting to go into production. You have this big queue of stuff waiting to go into production, which increases risk, increases cycle time, all those bad things. So beware the distributed monolith. This is not as fast as possible. This is the guy in Elf going, no! This is a recipe for a nervous breakdown. And actually, what this is Conway laughing at us. I told you about that. If you get all these people together and you form these short-lived teams and they run all around the code base, over time, your code base is going to coalesce into a distributed monolith in the limit. Back in 1968. So, that's all very well. What might good look like, though? I'm going to take a brief sojourn somewhere else. Could anyone recognize what this is? Ebola, someone shouted out. Ebola. It is. It is the Ebola virus. Might sound like a strange place to go to talk about business capabilities and decoupled software systems. But bear with me. So this is Pauline Kafiki. She was one of the 3 people who contracted, 3 people resident in the UK who contracted Ebola after going out to Africa to help with the crisis over there a few years ago. She's still alive, although still pretty sick. It seems to be incurable, pretty much, keeps returning. But Pauline was treated at the Royal Free Hospital in London, which is the UK sort of centre for infectious disease treatment, so level 4 containment and all that stuff. And this is from the Evening Standard, and this is a picture of all the people who were involved in caring, not just for Pauline Kafiki, but for the others. And this is the consultant, I think his name is Michael Jacobs, who wrote the piece in the Evening Standard about her care. And the interesting thing he said about her, well, I'll come on to that in a sec, but coming back to capabilities, when I imagined what a hospital would look like, I figured it was going to be pretty much the same as a normal big organization. Right? These different capabilities around microbiology, pharmacy, physiotherapy, estates, infectious disease control, different wards, domestic services, etc. This is kind of what I figured a hospital would look like. And of course, if you plot this sort of structure on a chord diagram, again, you get all this work flowing around the system, you get these queues, you get essentially lead times for getting stuff done being blown out. Blood tests take a long time if there's a lot of blood tests to be done. If you go on the bottom of a queue and there's lots of blood tests to be done, it's going to take a long time for your blood test to be done. And I thought, well, in the case of Ebola, right, where this is such an aggressive disease, you need to make decisions like this. You need to be able to keep on top of this thing really, really quickly to provide supportive care based on current levels of blood pressure and all that sort of stuff. I thought, how do they manage that in hospitals, in infectious disease units? I came back to this thing I heard about first from a guy called Mike Nygaard. He was talking about the OODA loop. This was developed by fighter pilots, or a fighter pilot, Colonel John Boyd, many years ago now. He was a fighter pilot in the Korean War, and post the Korean War, he helped to develop the US Air Forces and then most major Western armed forces doctrine on warfighting, essentially. And it's based on this idea that if you can execute this OODA loop, observe, orient, decide, and act faster than your opponent in a military, originally it was in terms of air-to-air combat, if you can go through this OODA loop faster than your opponent, then you're going to win, you're going to succeed, right? To give you an example of how important this is in the military, this drove the adoption of single-engined fighter planes rather than twin-engine fighter planes, because single-engine fighter planes were more maneuverable and allowed pilots to go around this loop faster. Anyway, I was thinking, what these doctors want to be doing when they're providing care, right, in this environment for Ebola treatment, they want to be going around this OODA loop as fast as possible, deciding things as fast as possible. Now, how do they do that? So this is a list of all the people involved in Ebola care. These are all the clinicians involved, the thin end of the wedge. And these are the support staff involved. This is the list of people that Dr. Michael Jacobs gave. And there's actually there's twice as many people in supporting the clinicians in Ebola care than there are in actually like being clinicians treating Ebola care. And if you look at these people, there's things like housekeepers, domestic team leaders, deep cleaners, engineering supervisors, whole loads of people that you wouldn't think could have any relation to actually treating Ebola on the front line. What he said was, if you imagine all the functions a hospital has to have, not only the doctors and nurses, blah, they all have to be involved. Essentially, what he's describing is breaking these capabilities, these sort of distinct silos up, and creating an infectious disease capability. And that's what they did, with all the roles that were necessary for treating infectious disease. And that sounds quite similar to how XP teams have been working for years, how Scrum teams have been working for years, lowercase a, agile teams. Cross-functional teams, single purpose, focused entirely on a customer's outcome and organized around a capability, in this case, infectious disease treatment, the what of what the hospital does, not how it does it. This is interesting, some interesting data from ThoughtWorks about the impact of work leaving your teams, right? The delay that can be caused by work having to go outside your local team boundary. So in the case of the hospital, if you had to wait and send stuff to the pharmacy, send stuff to the blood testing unit, put it into the back of the queue, wait for it to go through the queue, and then get your results back, right? In our study at a large Australian telco, we found that user stories leaving a team cycled an order of magnitude slower than those that stayed within a team. An order of magnitude, right? That's a massive increase in the cost associated with delay of the work not getting into production in this case. And this is true in terms of trauma teams in hospitals. My sister's an A&E nurse, and this is exactly how you treat major trauma in hospitals. You have a team that comes together, cross-functional, to treat major trauma. This is true for Formula One teams. It's not just the driver on testing day. It's the driver, all the engineers, cross-functional team, single purpose, organized around the capability. And it's true in the military around things like reinforced battle groups. All the Western military has now reorganized itself over the last 40 years based around cross-functional teams with a single purpose. Maybe the war fighting thing is a bit too much. So as software existence proof, back to software. If we look at our standard organization, what might that look like if we put these cross-functional teams together? Well, if you have these cross-functional teams, you don't have these distinct development or testing or PMO groups. You have these cross-functional teams, subsuming some of these other functions within those cross-functional teams. And this should be quite familiar. An example, this is from Compare the Market some years ago. I noticed the .NET Rocks guys are in town. I actually did a podcast for them about the journey that Compare the Market went on, this journey. And what they had was a big monolithic application, right, with all the different capabilities, selling motor insurance, selling home insurance, selling pet insurance. You can insure your pets, who knew? And a big monolithic database. And over time, what they've done is they've separated these capabilities out into separate bounded contexts, separate product lines, if you like, or market segments. And so they ended up, over time, and this has taken 5 years to do this. I'm not saying this is an easy thing to do by any stretch of the imagination, but they've broken out the individual product lines into separate bounded contexts, separate capabilities, each owning their own data, communicating, in their case, via messaging between capabilities. So home, motor, life, and some cross-cutting things, right? So my account, or managing my account. And then they have cross-functional teams that are delivering these capabilities independently. Have we got anyone from Compare the Market in, by the way? This is the sort of place they'd come to. No. Oh, they can't disagree with me then. And back to Conway's law, right? You've got these cross-functional product teams, long-lived. They've got their own backlogs that they manage and they work through. So they've got their own, they know their own cycle times and can predict how quickly work can get done and so on, or how much throughput they've got. And because they're in these distinct product teams, it reinforces the boundaries, the architectural boundaries between each of them. So the motor insurance team is entirely decoupled from the pet insurance team. The account management team is entirely decoupled from all the other insurance product lines. It's Conway's law in action. So what does that mean for us in terms of the work flowing through the system, delay, getting stuff done faster, and so on? Right, we want to go as fast as possible. Well, it's had an impact, right, because we've removed a ton of these queues from the system. And Conway is still going, you've still got some queues though. That's all right, because we can play the continuous delivery Jez Humble card. This is actually from a card game you can buy. This is Jez in this card game. I think there's one of Dan as well, isn't there, Dan? DevOps, woo! We can play that card, right? Well, build it, run it. Right. We don't just have cross-functional teams. We bring in operations into those teams as well. Terry Pratchett said, by the way, if you ever use any use of more than 2 exclamation marks is a sure sign of a deranged mind. So you can make your own judgment about me based on my use there. So what we do is we say, we're going to bring some site reliability engineering into our cross-functional teams. And our teams are going to be responsible for not just building the software, but also deploying it, also managing it when it's in production, being woken up at 3 o'clock in the morning. Interesting things that have happened at Compare the Market when I was there, because we moved to this model of owning our own infrastructure, owning our own deployment. No one wants to be woken up at 3 in the morning by a pager, essentially. And it's an interesting use of psychology that if you give people the ownership of that kind of aspect of software delivery, then people tend to respond by writing code in a slightly different way. Both in terms of trying to add more resiliency patterns in, so architectural safety measures, things like circuit breaking, bulkheads, these sorts of patterns tend to be used more. But also, another example would be when you start to understand the value of the software that you're building. All right. Previously, before they moved to this sort of build it, run it, sort of ops moving into the product teams model, no one really knew how much money was being made by each of these independent products. Someone did, obviously. Someone in finance and someone in data analytics knew. But none of the teams actually knew what the impact that they were having actually on the company and therefore on their colleagues and pay and so on. So based on this sort of model, each of the teams could start to prioritize things like visualization of key business metrics. So I was on one particular team, the managing accounts team, and we put some very sort of noddy, really, graphs in based on statistical analysis of how much money the company would make on click-throughs from our page. And it turned out it was making an awful lot of money. And suddenly, when you've got a near real-time picture on the wall, a graph every day saying your team has made X amount of money per day, suddenly making changes to the software is slightly different, or deploying the software becomes slightly different from a psychological perspective. So anyway, as an aside, moving on. So you move these operations groups, maybe you call them site reliability engineering or whatever, into your build it, run it team. Hooray. That's good. Conway's saying that's good. So each of these capabilities, the idea is they can be tested and deployed independently from one another. They're decoupled, they're cohesive. Conway's law is acting to preserve cohesion of these capabilities and to decouple the software within them from software in neighboring teams. Right? So you can change them independently of one another. Right? You can go faster. So this sort of number of queues in the system, better potentially than this number of queues in the system. We've got less delay in stuff moving around. I said that earlier about an order of magnitude difference in time it takes to stuff done if you move work between teams. So we're getting faster, we're getting the ability to deliver more value more quickly for our organizations, for our customers. But can we go further than this? And I think we can. I'm going back to Dr. Michael Jacobs again. He said, if you imagine all the functions a hospital has to have, not only the doctors and nurses, but estates management, food, facilities, and laundry, they all have to be involved. He doesn't say, except for those pesky business people, or except for those pesky food and facilities and laundry people. Everyone in the organization has to be involved. And I think that's where a lot of organizations are starting to move to now, which is to move away, and some examples in a moment, but to move away from this idea of having the business across this separate chasm from IT organizations. So what my colleague Ian Cartwright refers to as business and architecture isomorphism. So the idea that if you look at your business and look at your software systems, they should look the same. And if you're a business person looking at your software systems, they should look the same as the business that you've built. And what this means is, again, taking it to the limit, is that potentially those functions should move into these independent product lines, right? Into the product teams. And I'm not just saying we have a product owner maybe and a product manager and portfolio management is done with the business people. I'm saying those business people move into the teams as well. So we no longer have a discrete sales function. We no longer have a discrete marketing function. What we have is the people involved in marketing home insurance sit with the home insurance teams. They're not in their separate function anymore. Now that starts to get a bit weird, right? That starts to get a bit scary. What about economies of scale, you say? What about the fact that we're going to gain something from having all the people with the same set of skills sitting together? Well, depending on the type of organization you are, whether you're focusing on delivery of value or cost reduction, essentially, it might make more sense if you're focused on delivery of value to have those people in the teams, since you're going to minimize delays. And this is what it's all about, right? Minimizing the delay in getting valuable software out into production. If we have to wait to talk to all these other business departments, business units, before making decisions, putting work into their queues, anytime work has to leave your team, you introduce delays. So this is what organizations are moving to, the traditional business functions into the capabilities based on build it, run it teams. So suddenly, we've just got this massive one big company with everyone in this cross-functional team. That kind of doesn't make sense, right? Well, Spotify famously have started talking about this idea of, some years ago, squads, chapters, and guilds. I think they publicly said recently, don't do this. I understand the blog said don't do this. But I'm pretty sure that the reasons behind directly moving to a, quote, Spotify model would be bad, is that you have to go on the journey yourself. And the journey you go on may end up looking something like this, squads, chapters, and guilds, or it may end up looking slightly different and bespoke to you. But in essence, the idea is you have a team, cross-functional team, delivering, organized around a capability, delivering value. You have a collection of teams. So you have this starting to get this concentric structure based around capabilities, and then product lines or market segments, and then chapters, which is essentially taking the place of what used to be the development function. So maybe some line management or. So this is a diagram of a company we've worked with extensively for several years in Australia, as you can see. It's pretty clear. So what they've done is they've organized in a slightly different, they've organized sort of in the Spotify way, but they've called things slightly differently. So they've said, we're going to organize around market segments. They sell property, right? Rental property, and they sell property. And they sell commercial property and residential property. And they rent commercial property and residential property. So they've separated each of these things out into a different market segment. And all the people associated with that, sales, marketing, as a managing director, etc., they all sit within that market segment. So this is where we're subsuming the business functions within our sort of cross-functional groups. Within those market segments, you have groups of teams that they call value streams. And each of those value streams delivers something to some consumer somewhere. So in the case of residential property, there might be a channels team who delivers the web channels for commercial property or residential property. And each of those value streams are decomposed into smaller numbers of teams depending on scale. So that's essentially this idea of this concentricity ordered around business capabilities, taking advantage of Conway's law, one step further again, right? Taking advantage of this business and architecture isomorphism idea in order to reinforce boundaries between teams and between software systems. And each team owns one or more microservices in that case. The team size is about 10 to 20. This is sort of XP size teams. They scale up to groups of about 160 to 200. Does anyone know what that number might be? Shout out. Dunbar's number, perfect answer. Dunbar's number, the number of social connections you can hold in your head at any one point. So actually ThoughtWorks was originally built around the idea of you should only have an office with about 200 maximum people in it, because then, over that number, people are strangers to you. Whereas under 200 people, you can know people's names. You can ask them about whether they went to the football on the weekend or whatever it is. So scale in terms of XP-sized teams up in units of Dunbar's number and multiples thereof. It's these concentric circles of teams and teams of teams. It's another interesting bit of data that comes from Thomas Allen back in 1977. So I spent some time doing some research before I wrote co-authored a paper with Martin Fowler on the effect of distance on software development, backing up the Conway's law thing. And I came up with this, or Martin pointed me at this. This is originally a PhD thesis. And in this, he proves that the amount that you communicate with a colleague about something work-related, right, serendipitously, it varies inversely with the square of distance. So if you actually you can see the probability of weekly interaction is on one axis and distance in meters on the other. You've got a 0.05% chance of randomly having a conversation about something useful every week if you sit 10 meters away. Right? It's just negligible. It's not going to happen. Right? So the actual impact of this is, well, I guess in an amusing way, if you know two groups of people don't like each other, sit them on opposite sides of the building. But in an interesting way, if you want to have a library somewhere, do sit it at the opposite end of the building. Right? But the chances of having a weekly random conversation with a colleague varies inversely varies with the inverse square of distance. And that has some, again, interesting impacts on team structures. If you sit people close together, you're going to have this high bandwidth again. This is Conway's law. If you sit people further apart on different continents, obviously they're a long way apart, very low bandwidth. They're not going to talk very often. Right? So what does that mean in terms of how we architect our systems? Well, simply, you get people sitting a long way apart to work on bits of the software that are a long way apart, or that you want to be a long way apart, because they will separate over time. And this is true, incidentally, for things like stairs. It's not just horizontal, it's vertical distance. You put 2 flights of stairs in, and people don't talk to each other anymore. So, what does this mean? Well, it means, essentially, we should be co-locating the people that we want to talk a lot as much as possible. Right? Get the people who are working on the same thing, right? These long-lived product teams, put them in the same place. Right? And over time, that part of the system will become more cohesive and decoupled from the other parts of the system. Using the open source model, if you've got lots of people scattered all over the place, you should expect the things that they're working on to become very, very decoupled over time, or more decoupled over time, I should say. So co-locate as much as possible and take advantage of serendipitous conversations. So, in summary, as you chunk up from this idea of a small group of 10 people team to value stream, a group of these teams, to market segments, and then finally to companies, we should probably be thinking about using Conway's law and how that impacts the systems that we're building. We can use Thomas Allen's research to sit people who are working on the same thing together, and then we can use Dunbar's number to make sure that people actually share a similar social contract with one another. And also, whenever work leaves your team, you incur a very high cost. I did have a hypothesis earlier on, and this is This is the result of that hypothesis. And it's called the chunking up from microservices to teams to value streams to market segments to organizations practice onion. I might need a better name for this. I'm not very good at naming. It's one of the two hardest things in computer science, as we all know, along with cache invalidation and off by 1 errors. Moving on. So, what I've said is service boundaries, right, are synonymous with team boundaries. They are equivalent, right, if Conway's law holds. And therefore, we can use organizational boundaries to reason about how cohesive our systems are, how decoupled our services are, which testing types we should be applying, which integration patterns we should be using. And some examples of this, right? So this is in between organizations or between very decoupled parts of your organization. APIs at that sort of level of those boundaries, you tend to want them to exhibit low change rates and very high stability. Now think about, say, the Google Maps API, all right? You don't want to be changing that all the time because the millions of people who are relying on that are going to be a bit pissed with you, I think, to be honest. So what sort of patterns could we apply at these very high stability boundaries? And I've got a few examples. So the first one is semantic versioning. So semantic versioning is not a new idea, but I don't think enough people actually apply it rigorously. So this basically says that we should have very strict definitions of what sort of changes require bumps in version numbers of our APIs. Right? It's really, really straightforward. It says if you make a backwards incompatible change, you should bump the major version number of your API from 1 to 2. If you make a backwards compatible change, right, you should probably bump the minor version number. And there's a whole ton of other rules. Right? So semantic versioning probably makes sense to apply that at organizational boundaries. Right? APIs we're offering the outside world we should use semantic versioning as a technique. But what about these other ones? Say contract testing. So consumer-driven contracts have been gathering pace as a technique recently to improve stability of APIs and to further decouple teams from one another. And essentially what it means is I'm, as the consumer of the Google Maps API, someone who uses it on my own, in my own system, if I was going to use contract testing or consumer-driven contracts, I would write a test that describes how I use the API, the behavior of the API, and I would give it to Google for them to run for me every time they run a build. Now, that's not going to make sense in terms of Google Maps API, right? The number of people who are using that API, the number of different ways that they use it, Google would have to be running millions and millions of different consumer-driven contract tests every time they made a change. So it probably doesn't make sense to apply that technique. What about between different parts of an organization, different value streams, say, within a market segment, or different tribes, even if you're using the Spotify lingo? Well, probably you still want to apply some form of semantic versioning. But at this point, it probably makes more sense to apply contract testing, to write tests and give them to the service providers. It also probably makes sense for consumers of APIs across these boundaries to use the tolerant reader pattern. So the tolerant reader pattern, essentially, it's an executable form of the principle of robustness. It says I'm only going to bind to the things in a message or in a document that I absolutely require. Anything I don't require, I'm not actually going to bind to. So probably I should be applying the tolerant reader pattern locally. What about conversational change? This idea that I can just have a chat with Kate about, I'm going to make this change. Is that all right, Kate? Yeah, it's fine. I'll deploy my stuff. Well, you probably want more stability than just conversational change between these boundaries. Between teams, similarly, you probably want to apply these things. But what about within your team? There's 10 of you. You're working on a long-lived set of services. You've got your nice backlog that you're working through. Should you be investing in semantic versioning of the APIs between services that you're working on? Should you be investing in writing consumer-driven contracts for someone who you're sitting next to? Maybe the investment isn't worth it. Maybe instead you rely on tolerant reader pattern and actually having a conversation with the people you're working with instead. So this is the idea that if you break your software up into these so if you break your organization up into these along these lines, your software also ends up broken up along these lines. And you can end up applying different patterns between different parts of your organization. So, some thoughts to finish. I've talked a lot, there's a lot online, about me talking around some of the other points and some of these other characteristics. This talk was about this idea that, in my opinion, successfully adopting microservices is more than just componentization via services. It's not just breaking stuff up into small things, right? It's how the organization looks, whether you're running long-lived product teams, whether you're doing this sort of build it, run it thing, organizing around stable concerns of the business, these business capabilities, and so on. This is as much a part of the microservices, as much a part of the success of the organizations that adopted microservices as any of the other things like smart endpoints and dumb pipes and decentralized governance and so on. My colleague in Australia has got a beautiful description of some of the implications of this. He calls it the inverse Conway manoeuvre. What he says is, design the organization you want, and in the limit, the architecture will follow, kicking and screaming. That's Evan Botcher in ThoughtWorks. So if you design the organization you want, if you design a decoupled organization based around cross-functional, including business teams, over time, your software will end up looking like that. So Conway's law, I think, sends us signals. These are some of them. The first one is constantly ordering work across different capabilities. You know, if you've got to sort of split requirements up and hand one bit over here and one bit over here, that's probably Conway's law sending us a signal that something's not quite right. Again, splitting stories between teams, constantly moving people around. Having to deploy everything all at once, that's probably a sign that Conway's law is kicking in. This idea of fanning in for end-to-end testing, everything has to be tested together. And also there's this idea of a high cost of work associated with, work leaving your team. You know, if you're constantly having to raise tickets with another group in order to get stuff done, if you're handing off work to other departments a lot, if you're constantly starting and stopping projects, this is all, again, I think these are all signals that maybe the organizational structure, the team structure that you're working within isn't quite right. So I'm going to finish up. I've got 9 minutes, I think. So I can take some questions. I'm going to finish up with the last word. This is an email I received a little while ago. It says, "Hey James, I've recently come upon your presentations go faster than your competitors, how I finally stopped worrying and learned to love Conway's law," which were earlier versions of this talk. No, I am not sitting in the balcony laughing. I'm sitting at my computer learning from you, and your depiction of me as a Muppets figure helps to keep me humble. Keep up the good work. That was from Mel Conway. So, blessed with Mel Conway's stamp of approval. Mic drop, except it's on my head, so I can't. Thanks very much. Questions? There's one at the back. Yeah, so the question is, how do you actually go about doing this, right? How do you actually refactor your organization? So I'll give you two very vague approaches, right? The first one is you can either do it top down. So the organization in Australia, the real estate company, they actually got the senior management team together, so the C-levels, and they said, this is what we're going to do, broke the company up and said, right, now you all sit in these bits, right? So that was a very top-down approach to it. I think there's also an approach which is to gradually move there over time. That's going to take a very long time. I mean, so in terms of compare the market, they decided to pick one of these things and see how it worked, right? Fairly low-risk thing, and then move on to the next thing, move on to the next thing. And over time, they saw that they were reaping benefits from it. But when I say it takes a long time, that approach is still ongoing there, right? So that was May 2011. I was first there. And yeah, it's still ongoing. I know this because I'm still mates with their chief architect. Any further detail? Did I mention I work for this software consultancy called ThoughtWorks? Any more questions? Sure. So the question is, if you've got sort of, I guess, specific roles associated with technology, Yeah, the network. We've got network engineers. You've got a bunch of people who have got very niche roles, who sit in a network team or sit in who sit in a database, a DBA team. So one of the things that's becoming really popular, I'm seeing a lot of inquiries about helping do this. Was popularized by, I guess, Google, Netflix, around this idea of creating site reliability engineering functions. Which are, so in the Netflix sense, they're product development teams that happen to focus on providing software services to the rest of the organization in a self-service kind of way. So it's not a traditional ops team where you have your DBAs and your networking people and so on. But you have engineers who may include those people providing, say, self-service access to programmatically create networks, right? But you build a product that you offer to the organization in a that they can use in a self-service way. There's another model I quite like is that not only should they do that and offer that sort of service, but they should also be, those engineering teams should also be offering consulting to the rest of the organization. They should be offering, kind of better practice approaches to doing stuff. So an example would be continuous delivery, right? It's quite common or popular to have a centralized continuous delivery server farm. And if you want to do continuous delivery, you get onto your central continuous delivery server farm. But of course you end up with all these tickets you have to create, and you have to play by exactly the rules of the people who've built the hardened continuous delivery server farm. So in that model, in the model I'm just describing in terms of site reliability engineering, that group providing that might say, well, look, we've got this really cool, hardened, secure CD farm that you can use, but we've also got a bunch of approaches that we've used to build that. And so if you don't want to use our central thing, maybe you could learn about how we did it and take our guidance and advice around it and build it yourself. Or maybe they provide, Docker files that you can spin up your own version of the security, the hardened farm sort of thing. But it's going back to this idea of self-service, reducing tickets and reducing the fact that you have to wait on work in someone else's queue in order to get your own work done. I'm not suggesting in this world any of those more specialized roles go away. I think what they will end up doing, much in the same way that testing changed with XP and with Agile, right? Testing, I hope, in most organizations is no longer someone sitting there going through big, long scripts. It's more, I'm going to be writing some automated tests in order to drive quality, rather than passively sitting there clicking through test plans, and then doing the cool stuff, which is exploratory testing, rather than network engineers waiting, getting a ticket, I'll open the firewall port. A network engineer now has the cooler job of building the ability for the teams to use the networks in a software programmable way or whatever. So I tend to ramble a lot with questions, answers. Does that answer the question? Also, ThoughtWorks. Anything else? Okay. I'll be around. Can I remind you there's tickets and things to rate stuff outside, so please do that. It's very useful for the organizers and for the speakers in order to get feedback. So please do that, and thanks very much for coming along. I appreciate it.